Black holes are the universe's delete button, and it's proof of the simulation. The warning light on Hawking's desk phone was blinking when the calculation finished. The equation said black holes leak. If that was true, the ultimate vault in nature had a hole in it, and not just for matter. For information, the thing quantum mechanics treats like immortal currency. You'd think the field cheered. Instead, the room went quiet. Because if black holes evaporate, what do they do to the data they swallow? Get this, the official line says information can't be destroyed, yet the math looked like a shredder. To see why the story bent that day, we start where they say the truth broke, March 1, 1974. 1974, the spark they downplayed. Stephen Hawking wasn't trying to be a wrecking ball. He wanted a clean answer to a neat question. What do quantum fields do near a black hole's edge where spacetime curves hard? Classically, the event horizon is a one-way door. Cross it and your messages never make it back. But quantum fields don't respect neat borders. They jitter. They borrow energy and pay it back fast. Here's where it gets interesting. Empty space in quantum terms is busy. Virtual particle pairs appear, hug, and annihilate before anyone can catch them. Near a horizon, the tidal pull can rip a pair apart. One falls in, the other escapes and gets promoted to real. If enough of those survive, the black hole looks like it's emitting something. Not a metaphor, radiation with a temperature you can write down. Hawking did the math. Using quantum field theory on a curved background, he found a precise spectrum. Black holes aren't perfectly black. They radiate and, given jaw-dropping timescales, evaporate. That line, black hole plus time equals nothing, detonated the field. Because if a hole shrinks and vanishes, what happens to everything it ate? Now remember, this is 1974. Hawking's paper hit Nature on March 1. Particle physics is flexing. Unitarity, the rule that a pure quantum state stays pure, feels sacred. General relativity rules its own kingdom with geometry and horizons. Hawking dragged them to the same table and made them argue in public. In Cambridge hallways, the first response was denial by interpretation. Maybe the radiation is featureless, but the information hides, in a remnant, in subtle correlations, in some later effect. Hawking doubled down. The radiation is thermal, no fingerprints, so the details don't come back. Throw in a dictionary, get out warm noise. If that stands, a pure state becomes mixed. In quantum mechanics, that's not a smudge, it's a tear. Microstory from those days. A young theorist copies Hawking's derivation line by line, hunting a loophole where the dictionary could still be hiding. Temperature term check. Horizon redshift check. Bogoliubov coefficients check. He erases, rewrites, adds a minus sign, stares. The spectrum stays thermal. He drops the chalk. It rolls under the radiator. 20 minutes later, a senior professor steps in and says quietly, "It's either the end of unitarity or we're missing the map." Meanwhile, an earlier whisper grew louder. Jacob Bekenstein had argued that black holes have entropy proportional to area, not volume. Hawking's result fixed the constant and turned audacity into a law. S equals A4 in Planck units. Entropy wasn't a metaphor. It had a temperature and a count. Every bit the hole could hold lived on its boundary. But 1974 wasn't the year for whispers. It was the year for panic about memory. If black holes evaporate thermally, a pure state could evolve into a mixed state. That's forbidden in standard quantum theory. The paradox was born, two pillars, one breaking the other. You can feel the stakes in letters and seminar jokes that weren't really jokes. John Preskill would later bet Hawking that information gets out. Hawking said no. He was exact about what his math claimed. Semi-classical gravity predicts evaporation with thermal radiation. If that's the whole story, information is lost. If it isn't, quantum gravity must be unitary in a way his calculation couldn't see. Conferences convened. Fixes surfaced. Remnants, tiny leftovers with impossible libraries. Baby universes. The data exits our branch safe but gone. Modified quantum mechanics, the rulebook changes. Each carried a price: energy bounds, infinite species problems, untestable detours, or rewriting the very theory every lab depends on. Microstory, Princeton, a Penrose diagram on the board, collapse, horizon, evaporation. A hand shoots up. Show me the map that takes a pure state here to a pure state there. The speaker says it's scrambled. The hand stays up. By whom? Nervous laughter. Not unkind, revealing. Scrambling needs a scrambler. Something else was stirring. Bekenstein's area law refused to sit quietly in thermodynamics. If entropy counts microstates and scales with area, the boundary is doing more than decorating the bulk. It's keeping the ledger. Treat it as bookkeeping if you like. The budget still binds. In the culture, the label paradox did two things at once. It made the problem respectable and bought time. Time for tools we didn't have yet. Time for a generation raised on quantum information to speak geometry and qubits in the same sentence. But it also softened urgency in public. To most people, black holes stayed monsters. To insiders, they turned into auditors. Human moment. After a talk, students gather around Hawking. Is the information really gone? He smiles, then keeps the field honest. With the calculation as it stands, yes. And then he leaves the door open. If quantum gravity is unitary, the resolution lies beyond semi-classical gravity. This was the hinge. A black hole wasn't just an astrophysical object. It was a test of whether reality keeps receipts. The paradox wasn't a curiosity. It was a crack between our two best theories. To follow that crack, we had to follow the information, to the boundary, to entanglement, and to a suspicion that space itself might be a rendering of a ledger that never forgets. The rule that can't break and does. To feel the panic, say the rule out loud. Unitarity. Quantum mechanics evolves pure states to pure states. Reversible in principle, information preserved. You can scramble the message, but you can't delete it. The wave function doesn't forget. Put that beside the other pillar, general relativity's event horizon. Classically, it's a one-way surface. Cross it and signals can't reach infinity. Combine them with Hawking's thermal spectrum and you get a script nobody wanted. A pure state falls in. A mixed state comes out. That's not a cosmetic error. It's a fracture in quantum theory's spine. Stakes cleanly. If unitarity fails even once, quantum field theory everywhere grows suspect. Probabilities don't add up in subtle ways. CPT symmetry shivers. Worse, predictability. The quiet promise that state today fixes future statistics stops holding. Technologies that rely on coherence become bets. If nature sometimes erases, what stops it from erasing anywhere? Action played out as dueling thought experiments. The campfire first. Toss an encyclopedia into flames. Locally, the smoke looks thermal, but globally, if you could measure every molecule and photon, correlations encode every paragraph. Unitary evolution scatters, it doesn't annihilate. Hawking's calculation said black holes weren't campfires. They were shredders. Throw in ants, get fog with no correlations you can use, at least none that show up after evaporation. Then the blender analogy. Maybe black holes are extreme blenders. The output looks random, but if you measure precisely enough, hidden structure appears. That needed a mechanism injecting correlations into Hawking quanta. Semi-classical gravity showed none. The spectrum was thermal to all orders you could compute. The blender needed a new motor. Meanwhile, geometry kept repeating its line. The horizon blocks causal return. The radiation you do see is produced just outside by quantum fluctuations. The inside doesn't get to send messages out. The courier can't cross. Impact landed as a corner choice. Some said bend unitarity, allow fundamental information loss. John Preskill and others drew a line, break unitarity, and you wreck quantum theory far from black holes. Others bent geometry's story. Maybe horizons aren't smooth. Maybe the boundary encodes everything and re-emits it later. That instinct fit Bekenstein's area law, but the dictionary was missing. Human moments sharpened the edge. Princeton, a seminar room. Someone taps the Penrose diagram and says, "Show me the unitary map from collapse to evaporation." The speaker answers, "It's scrambled." The reply shoots back, "By whom?" Nervous laughter again. Scrambling needs a scrambler that respects causality. What nobody knew then was how crucial entanglement bookkeeping would become. Hawking pairs are born entangled across the horizon. The outside mode is correlated with an interior partner. Early on, fine, but keep emitting and the accounting snarls. Late quanta must be entangled with early radiation to restore purity, while still entangled with interior partners to keep the horizon smooth. That violates monogamy. One qubit can't be maximally entangled with two independent systems. Something has to give. So the field took a posture, call it a paradox, and map its edges. That label bought rigor. Baby universes exported information to unreachable branches, unitary globally lost to us. Remnants stored absurd libraries in Planck-sized vaults, flirting with infinite species and energy bounds. Modify quantum mechanics. You rewrite the rules that every lab relies on. Each fix broke something sacred. Microstory, a hallway exchange at a conference. A young physicist says, if the output's unitary, there must be correlations. Where? A senior replies, somewhere we don't calculate. The younger laughs, then stops. That sentence is both hedge and dare. Meanwhile, another whisper kept nudging. Bekenstein's entropy scales with area. If a horizon's surface counts microstates, the boundary isn't decoration. It's the ledger. Treat it as bookkeeping if you must. The budget still constrains everything you can do. The volume starts to look more like a rendering than a warehouse. Stakes tightened as language hardened. If you keep unitarity and keep no drama at the horizon, you owe a map that routes correlations to the radiation on time, before the whole disappears. You also owe a reason the outside quanta aren't double entangled. If you keep Hawking's thermality as literal, you owe a place where quantum mechanics bends without breaking everything else. If you keep general relativity's calm horizon, you owe subtle non-locality that doesn't let you signal faster than light. The room for hand-waving shrank. Human angle, a colloquium Q and A ends with a simple demand. Draw the page curve for your fix. The speaker hesitates. The curve became a litmus test people couldn't dodge. Rise, peak, fall, or fail. What nobody saw clearly yet was the shape of a loophole that didn't cheat. If entanglement patterns aren't just correlations but structure, if they stitch regions of spacetime, then the interior partner might not be an independent system at all from the perspective that guarantees unitarity. Maybe it's encoded in the radiation once you've collected enough. That sounds like a trick until you remember quantum error correction, where a message hides across many qubits, reconstructible only from large subsets. The paradox survived because it was honest about the collision. It also concealed a path. Treat the ledger seriously, elevate entanglement from curiosity to scaffold, and look for a dictionary that makes unitarity obvious. The next beats chase that dictionary. The cover story, how paradox became policy. While theorists fought over maps that didn't exist, institutions did something smoother. They standardized the word paradox. It sounded honest, admitting we didn't know, while quietly setting guardrails for what you were allowed to say. The stakes weren't abstract. Careers hinge on tone. Funding panels like unsolved problems they can fund for years. Textbooks prefer tidy mysteries to untidy revisions. Paradox parked the car on a safe shoulder and told everyone to gather around. Action step by step. A workshop in Santa Barbara opens with a careful script. We'll frame the information paradox and survey candidate resolutions. Survey is code for we're not picking a winner. Slides cycle through remnants, baby universes, modified quantum mechanics. The concluding line, more work needed, lands like a stamp. The proceedings read, unresolved. Next meeting, same choreography. New buzzwords, same verdict. Meanwhile, papers learn to speak in disclaimers. We note implications for the information paradox, though a full resolution is beyond our scope. Reviewers circled any sentence that sounded final and wrote, speculative, soften. Softening became a style guide. Suggests hints may indicate we conjecture. Young postdocs absorb the rule. Don't be the person who declares the vault open. Impact spilled into public messaging. Press releases leaned on mysteries that defy explanation. It sells. It also tranquilizes. The audience learns that nature hoards secrets, not that equations are tightening the ledger. Insiders gatekept with good intent, avoid overclaiming. But the result was a culture that polished the question like an heirloom. Displayed, admired, never used. Human moment. A junior researcher uploads a bold preprint. Boundary degrees of freedom encode bulk microstates. Evaporation is unitary. The math is fine, the tone is not. Backchannel advice arrives within a week. Partner with a senior, temper the title, add caveats. The revision reads like a truce. The core remains, wrapped in hedges that signal respectability. Microstory, a grant interview. Are you claiming to solve the information paradox? The panel asks. The candidate answers. We're clarifying entanglement structure near horizons. True, and also survival. Claim less, live longer. The paradox label protects the field's image and punishes anyone who moves too quickly toward a mechanism. Meanwhile, entropy refused to be background music. Bekenstein's area law fixed by Hawking's temperature wasn't a metaphor. It was a budget, S equals area over 4. That count lived on the boundary, not in the bulk. Institutionally, people compartmentalized. Thermodynamics on Tuesday, information paradox on Thursday, as if the number didn't bleed between rooms. But it did. If area counts states, the boundary knows too much for the interior to be sovereign. Gatekeeping adapted. Senior voices said, don't overinterpret area scaling. Useful, not literal, but across subfields, quantum information, holography, gravity, the same patterns kept surfacing. Minimal surfaces measured entanglement. Inequalities lined up with geometry. Boundaries behaved like accountants. You didn't need metaphors. You needed to read what the math was already writing. Human moment again. A colloquium QA. A student asks if the information S on the horizon isn't calling it a paradox, just branding. Laughter, then quiet. The speaker answers carefully. Paradox helps us avoid premature commitments, but entropy on the boundary is stubborn. Policy meets evidence and neither quite yields. What nobody noticed, because policy doesn't notice, was that the mystery had narrowed to bookkeeping. How do boundary bits rearrange as the whole shrinks? And when does the radiation's algebra gain the right to reconstruct interior operators? The answer needed machinery that didn't exist yet, but the paradox label didn't care about machinery. It cared about tone. Microstory, a grad office wall. A boundary correlator plot sits taped over a simulated black hole image. Their outlines rhyme. Visitors pause. No speeches, just a visual argument that metaphor had become map. The poster stays up all year like contraband that everyone pretends not to see. Meanwhile, the page curve crept into hallway checks. Great talk. Can your setup draw the rise, peak, and fall? If not, the paradox tag wasn't a shield, it was a verdict. The cultural script began to crack. You could keep saying mystery, but graphs started saying deadline. After the page time, the ledger must pay out. If your fix didn't turn the curve, policy had nothing to defend. Impact on students was quiet but deep. They learned a new dialect. Entanglement wedge, reconstruction, quantum extremal surface. Jargon, yes. Also a code for access control. Who gets to reconstruct what depends on which boundary pieces you hold. That's not vibes, that's policy written in geometry. The word paradox kept the public calm while the insiders built an operating manual. Human angle, late night coffee. Two physicists grin at a line they won't print. We're basically doing operating systems with tensors. It sounds like a joke until it doesn't. Allocation, scrambling, release. Budgets, clocks, permissions. The ledger is physics, the policies are laws. What nobody anticipated was how fast the culture would pivot once the machinery appeared. Replica wormholes and islands gave the radiation a legal claim on interior degrees after the page time. Holography gave a boundary Hamiltonian that never forgets. The paradox label didn't vanish. It just stopped describing the center of the maze. It became branding, while the math wrote policy. Here's the turn. If paradox was policy, the fix was process. Boundaries hold budgets, entanglement stitches space, and reconstruction writes shift on schedule. The next sections don't ask for belief. They run the ledger: holography, bridges as wires, the page clock, and the island clause that finally made the curve turn over. Bekenstein's number, the boundary whispers. Stakes first because this number doesn't blink. Entropy is supposed to scale with volume, more room, more microstates, more ways to arrange the stuff. That's what a gas in a box teaches you. Then Jacob Bekenstein came along and said something impolite to intuition. For black holes, entropy scales with area, not volume. The count of hidden possibilities lives on the surface, not in the interior. If that's true, the boundary isn't a fence, it's the ledger. And ledgers set limits that everything else has to obey. Action from the beginning. Early 1970s, Bekenstein is a grad student who refuses to let the second law die at the horizon. Drop a hot cup of coffee into a black hole and watch the steam and disorder vanish from view. If total entropy can't go down, the hole must gain an entropy at least as big. He argues that increase is proportional to the change in horizon area. He doesn't know the constant, but the slope is clear. More area, more hidden microstates. Hawking's 1974 calculation supplies the missing piece. With a definite temperature for black holes, the thermodynamic analogy turns into physics. Combine temperature with the first law of black hole mechanics and you land on SA4 in Planck units. No poetry, a formula with teeth. 1/4 of the horizon area measured in square Planck lengths counts the number of bits, up to a factor of log 2, a number that keeps showing up whenever you try to cheat. Human moment, an office in Jerusalem. Bekenstein draws a square on the board, writes on the boundary an S in the middle. A colleague says, entropy belongs to the stuff inside. Bekenstein taps the perimeter. Maybe the inside is not what you think. He isn't grandstanding. He's warning them that the budget lives on the skin. Impact radiates out. Take a sphere of radius r, volume grows like r cubed. Area grows like r squared. If the maximal entropy is A4, then double r and the number of microstates goes up by 4, not 8. The densest storage in nature is capped by a surface. That logic becomes the Bekenstein bound in spirit. No system inside a boundary can encode more information than a black hole of the same size. Gravity becomes an auditor. Try to overpack a region, and spacetime responds by forming a horizon whose area enforces a lower ceiling than your volume-based intuition promised. Meanwhile, details sharpen into rules. The generalized second law says the sum of ordinary entropy outside plus the area 4 of horizons never decreases. That's a hard constraint on allowed processes. Try any fancy quantum trick, a clever teleportation, a near-horizon shuffle, and the area adjusts to keep the total from dropping. Nature protects the ledger by moving the boundary or changing its cost. Microstory, a late-night chalkboard duel. A skeptic proposes stuffing a box with modes of a quantum field to exceed any bound. The other physicist starts tracing light rays inward from the box's surface. Watch the expansion, they say. The rays focus, the area decreases, a trapped surface forms. You made a horizon, the area just joined your count. The skeptic lowers the chalk and nods. The bound holds because geometry pushes back. What nobody realized at first was how this number would force a perspective shift. If the area counts states, then the degrees of freedom that matter live on the boundary. The interior can be real, and in Fowler crosses, clocks tick, tidal forces stretch, but the microstates that keep unitarity honest sit on the edge. That flips the story. The volume becomes a rendering fed by a finite boundary ledger, not an independent warehouse of bits that can grow unchecked. Stakes escalate when you tie the area law to entanglement. Entanglement entropy across a boundary scales with the area of that boundary in quantum field theory, up to divergences that renormalize into the same A4 term in gravity. The correction terms you add, bulk entanglement across the surface, aren't noise. They're the quantum fine print that tells you when the ledger updates. The same minimal surfaces that show up in holography as measures of entanglement creep in here as rulers. Human angle, a grad student stares at a sketch of a horizon tiled with plank-sized squares each a bit. The interior behind looks vast, the ledger looks thin. They scribble, if the surface holds the book, the interior is a reconstruction. They almost write illusion, stop and settle on code. They tuck the page into a drawer. The word feels dangerous and right. Meanwhile, culture tried to compartmentalize. Teach SA4 in the thermodynamics chapter. Put information paradox in the quantum gravity chapter. Keep the interpretations from chatting in the hallway. But calculations kept ignoring the partitions. Energy conditions, focusing theorems, entropy inequalities. They all moved in sync with an area that behaved like a counter, not a metaphor. The payoff lands as a direction arrow. If the boundary holds the bits and the interior depends on how those bits are arranged, you're pushed to a principle. A full description of a region might live on its boundary with one fewer dimension. Holography stops being a cute word and becomes a requirement if you want the math to stop contradicting itself. The number S equals A4 isn't just a trophy from the 1970s. It's the whisper that turns into a map. One that points straight to a dictionary where the boundary doesn't suggest the bulk, it equals it. The holographic leak. If the area is the budget and the boundary keeps the book, then the interior stops looking like storage and starts looking like a display. Not fake, experienced, measurable, lived, but rendered from data that sits on the edge. The stakes are obvious. If that's right, the information paradox loses its teeth because nothing truly vanishes inside. The ledger never hands its rights to a place you can't audit. Start in a clean thought room. Take a region with a boundary. In ordinary field theory, you'd say the volume contains independent degrees of freedom at every point, like pixels in 3D, but the area law won't allow that. Gravity caps how many independent bits the region can support. So flip the story. The independent degrees of freedom belong to the boundary. The bulk modes you thought were freestanding are correlated reconstructions, like a 3D scene built from a 2D array of pixels with efficient compression. Not poetry, enforced by S equals A/4. Here's a concrete image. Imagine a spherical chamber lined with a panel of tiny cells. Each cell holds at most 1 bit. You inside watch a 3D world. Fields ripple, particles collide, clocks tick. Someone outside touches only the panel, yet can predict everything you can measure at the surface with perfect accuracy. That's the rule. Any exterior measurement has a complete account on the boundary. The interior is the show, the panel is the script. Change the pattern on the panel, and the show inside updates accordingly. Now bring in a black hole. As matter approaches the horizon, the boundary degrees of freedom reconfigure. From far away, the ledger updates to reflect what's falling. Infalling observers still see smooth space near the horizon, no drama. But the exterior description never needed to follow the matter inside. It tracks the evolving boundary state that, in principle, encodes the infaller's data with no loss. When Hawking radiation emerges, it's not freelancing. It's the boundary releasing correlations, according to rules set by dynamics and capacity. That reframes Hawking's thermality. His semi-classical calculation treats the horizon as a stage in a bulk theory and finds a thermal spectrum. Except the boundary-first view and global unitarity is manifest in the microscopic theory. Local measurements on single quanta look thermal, while joint measurements across many quanta reveal hidden structure. The campfire analogy makes sense again, not because we added secret pipes in the bulk, but because we stopped insisting the bulk carry the pipes at all. The encoder is the boundary. Human moment, an office with 2 plots taped side by side. One shows boundary correlation functions evolving in time. The other is a simulated slice through a black hole spacetime. The shapes rhyme. A grad student grins. The advisor stops calling it a metaphor. When pictures line up without hand-waving, You either accept the map or explain a more miraculous coincidence. Stakes sharpen when you ask how information actually leaks. If each Hawking quantum looks thermal on its own, the data can only ride on correlations spread across many emissions. A boundary theory that's unitary and strongly mixing gives you a mechanism without extra gadgets. Time evolution scrambles information, then, after a delay, begins to emit structured correlations at a rate tied to temperature and capacity. The black hole looks like a specific encoder. Earliest emissions carry little structure, later ones carry more. With a schedule, the page curve will timestamp. Meanwhile, skeptics push. Show me a dictionary, not vibes. Fair. Early signs came from simple rules that tied entanglement entropy for boundary regions to areas of minimal surfaces in bulk geometry. You vary the boundary state and the minimal surface wiggles, changing area to track entanglement. That's not allegory. It's a prescription. It turns the boundary knows the bulk into a working calculator. Microstory. A young theorist gives a talk titled "Edges Know Too Much." A senior physicist interrupts politely, "Edges can't know interior operators." The speaker advances to a slide with a proof sketch, reconstructing certain bulk excitations from specific boundary subregions. Not all at once, they say, but enough if you hold the right pieces. The room goes quiet. The claim stops being taste and starts being algebra. What nobody knew at first was how naturally quantum error correction would slide into this picture. In a good code, one logical qubit hides across many physical qubits. You can lose a few and still recover the message. Holography seems to implement such codes by default. That means the interior operator, an infaller would measure, can be represented on different boundary subregions, depending on access. Lose some boundary degrees, errors, and the interior remains reconstructible if you control enough of what's left. That's the loophole in the firewall tension seen from the boundary. The outgoing mode that looks entangled with an interior partner has that partner encoded non-locally in the degrees of freedom you'll later call early radiation. Monogamy stops biting because you're not counting two independent systems. You're counting two reconstructions of one logical algebra. The smooth horizon survives for the infaller. Global unitarity survives for the accountant. The wire carrying correlations to the radiation isn't a bulk path. It's boundary time evolution. Human moment again. A late-night chalk session ends with a circle labeled boundary and a squiggly interior labeled bulk. Someone draws arrows. Scramble here, leak there. Another writes no drama next to the horizon and no loss next to the exterior. Pick both, they say, but only if you accept the edge is the book. The payoff lands clean. Once you grant the ledger sits on the boundary, evaporation isn't a riddle, it's a process. The paradox dissolves into timing and decoding, and the timing gets a clock in a special space-time where the dictionary is exact, the rules are explicit, and the area truly equals entanglement. A bowl-shaped universe with a theory on its edge that never forgets. Firewalls, when saving info burns reality. Here's where the horizon stops behaving. Those Hawking pairs we've been polite about, one mode out, one mode in, carry a hidden debt. Early on, the outside mode is entangled with its interior partner. Fine. But unitarity demands that after the page time, new quanta must knit themselves to the early radiation to keep the global state pure. One qubit can't be maximally entangled with two independent systems. Try it and the math snaps shut. That snap got a name: Firewall. Action came fast and clean. In 2012, Ahmed Almeri, Donald Maroff, Joseph Polchinski, and James Sully, AMPS, wrote down the clash with three assumptions many people wanted to keep. 1. Unitarity. The radiation ends up in a pure state. 2. No drama. An infaller crossing the horizon feels vacuum, not violence. 3. Effective field theory holds outside the horizon at scales larger than the Planck length. AMPS showed you can't have all three at once. If late-time radiation is entangled with early radiation to keep things pure, it can't also be entangled across the horizon. Break that entanglement, and the vacuum at the horizon isn't vacuum anymore. It's hot. So hot the infaller burns on contact. Stakes don't get more personal than this. The equivalence principle is the closest thing general relativity has to a promise. Locally, gravity is just free fall. A firewall breaks the promise right at the horizon. For decades, no drama was the truce between geometry and quantum fields. AMPS tore up the truce and slid you three choices. Keep unitarity and torch the horizon. Keep the smooth horizon and accept information loss. Or break effective field theory in a calm region. Pick your bruise. Seminars turned into courts. Relativists defended no drama like family. Quantum information folks pressed monogamy like a prosecutor with receipts. You could feel the room split by age and training. Was the horizon a special place after all? If yes, what mechanism cancels the cross-horizon entanglement without leaving detectable scorch marks? If no, where does the page turnover get its correlations fast enough? Microstory, a diner in Santa Barbara after a workshop. A napkin becomes a diagram, 3 circles labeled E for early radiation, B for the newest quantum, A for its interior partner. Lines for entanglement. Someone writes EB and AB, then draws a lightning bolt through AB. Firewall. Forks stop. Coffee goes cold. Nobody jokes for half a minute. Meanwhile, proposals multiplied. Some said embrace the burn, unitarity wins, the horizon isn't smooth and equivalence fails at the edge. It's ugly but consistent. Others offered state-dependent interiors. Define the interior operators in a way that depends on the global state, dodging monogamy with context. Critics said that's moving the goalposts. A different camp pitched nonviolent non-locality. Let subtle, long-range correlations leak information out without frying the infaller. The trouble was building a concrete, calculable mechanism that respected causality and matched the page curve. What nobody had crisp in 2012, but rumors were circling, was how reconstruction rights could shift. If bulk interior operators are logical constructs encoded across many degrees of freedom, then the A that B needs to be paired with might be reconstructible from the early radiation once enough has escaped. That's not cloning, that's code. In a quantum error-correcting code, one message has many valid reconstructions from large enough subsets. Monogamy doesn't bite if you're not double-counting independent systems. You're pairing B with one algebra seen 2 ways at different times. Still, the timing had to work. Past the page time, the algebra available to an outside decoder must expand to include operators you decall interior before the turnover. That's a sharp claim. It asks for a rule that tells you when and how the right to reconstruct crosses the horizon. Without that, no drama looks like wishful thinking stitched to a slogan. Human moment. A well-known relativist after an hour defending smooth horizons pauses and says, almost to themselves, I dislike firewalls more than I like comfort. Translation. Unitarity isn't negotiable. If something has to give, it won't be the ledger. Across the aisle, someone raised on circuits and qubits nods. They've been waiting for geometry to accept that entanglement bookkeeping isn't a garnish, it's the dish. Meanwhile, a different idea got legs. Maybe entanglement is geometry. Say it out loud, ER equals EPR. If every strong entanglement link is a thin, non-traversable bridge, then rerouting entanglement is reshaping spacetime. The wire between B and its interior partner can be re-expressed as a wire between B and the early radiation E. If the code makes a reconstructible from E you don't copy, you rewire. The infaller still experiences vacuum. The accountant still gets a unitary ledger. The bridge is non-traversable, no faster-than-light messages. But connections exist, and they carry bookkeeping. Microstory, a whiteboard with 2 arches. One connects the black hole to its bath of early radiation. The other straddles the horizon. Both get labeled with the same initials. Someone writes non-traversable 3 times and underlines it. They're not promising shortcuts. They're promising structure. Skeptics kept pressure on specifics. Show me the dictionary, they said. Where does the handoff happen? What calculation picks the moment? Fair demands. The answer didn't live in slogans. It lived in a boundary theory that never forgets and in a gravitational path integral that, when done carefully, discovers new saddles. Those saddles don't add drama for the infaller, they add clauses to the accountant's rulebook. After a certain time, the entropy of radiation isn't computed by ignoring the interior, it's computed by including an island. The algebra shifts. The vacuum at the horizon stays vacuum. The payout begins on schedule. This is the fuse that matters. Firewalls forced a choice. equals EPR offered a route. Islands wrote the clause that finally made the choice unnecessary. Keep unitarity. Keep no drama. Keep effective field theory outside. But update who has the right to reconstruct what and when. The next beat pulls that clause out of rumor into calculation. equals EPR, bridges or wires. Here's the claim that sounded like graffiti on a chalkboard and then refused to wash off. equals EPR. Einstein, Rosen, bridges. The wormholes you met in general relativity. And Einstein, Podolsky, Rosen pairs. The entangled states you met in quantum mechanics are two faces of the same connection. Bridges or wires. If entanglement is the microscopic glue of spacetime, then strong entanglement between two systems corresponds to a thin, non-traversable geometric link. You can't send signals through it faster than light. That stays sacred. But the link exists and it carries bookkeeping. Stakes first. If equals EPR is more than a slogan, you get a route around the firewall without cloning data or frying in fallers. The outgoing Hawking quantum B wants a partner A behind the horizon to keep no drama. Unitarity wants B tied to the early radiation, E, so the full state stays pure, and the page curve eventually falls. Monogamy blocks B from being maximally entangled with two independent systems. equals EPR reframes the cast. Perhaps A isn't independent from E in the full code. Perhaps, after the page time, the interior partner and infaller would call A is reconstructible from E, so the wire B needs is the same wire, seen two ways. Action step by step. Picture a black hole that's already emitted more than half its entropy. The remaining hole and the early radiation are highly entangled. In the bulk cartoon, you draw an bridge between the hole and its radiation, thin, non-traversable, but real in the dual description. Now emit a new mode B locally at the horizon. The state wants to look like vacuum, so B is paired with an interior mode A globally. Consistency wants B correlated with E if the code that builds the interior is a quantum error-correcting code. Then A isn't an independent degree of freedom. It's a logical operator that can be reconstructed from many different boundary subsets. Before the page time, that reconstruction sits on the remaining hole. After it migrates to equals EPR is the geometric avatar of that migration. The bridge that used to tie B to the interior now routes through E. Micro story. A whiteboard in Stanford, 2013. Two circles for hole and radiation, a thin arch labeled ER between them. Another arch across the horizon, also ER. Someone writes EPR by both arches, then underlines non-traversable. A visitor frowns. You're saying the interior is in the radiation. The reply is careful. I'm saying the interior operator the infaller measures can be reconstructed from the radiation once you hold enough of it. The room's quiet. The word enough is doing a lot of work. So is reconstructed. What nobody appreciated at first was how cleanly this dovetails with quantum teleportation and error correction. In teleportation, you don't copy a state. You consume pre-shared entanglement and send classical bits to recreate it elsewhere. In the wormhole picture, you can even make certain bridges effectively traversable by adding a precise coupling, a bilateral kick, between two entangled systems. Out pops a signal as though it crossed a wormhole, while every step respects causality. That protocol isn't a loophole. It's a demonstration that entanglement is a resource you can route with rules. Skeptics ask the right question. Where's the dictionary? Not vibes, operators. Holography answered in pieces. Bulk excitations near a region correspond to boundary operators supported on subregions that contain its entanglement wedge. As the radiation E grows, its wedge can come to include regions that were once inside the hole. The algebra of E expands until, after the page time, it contains the logical operator A that pairs with B equals EPR is the headline. Wedge reconstruction is the footnote that makes it calculable. Human angle, a seminar where the speaker draws the time slice of a two-sided black hole, the bridge fat when entanglement is high, thin when it's not. Increase mutual information, they say, and the throat fattens. Half the room smiles at the audacity, the other half at the precision. The phrase lands like a dare. If you want a thinner bridge, sever entanglement. If you want a path for decoding, build it. Meanwhile, something practical emerges. equals EPR isn't promising free comms. It's promising a wiring diagram for correlations. The wire that matters to the paradox isn't a tunnel you can fly through. It's the identification that lets one system's logical operator live in another's degrees of freedom. That's why monogamy stops biting. You never asked B to love two strangers. You asked B to love one partner that changes address in your description as the ledger updates. Micro story, a late-night group meeting. Someone writes AE on the board, interior A as a functional of the early radiation, and circles it. State-dependent, a skeptic warns. Contextual, the presenter nods, but consistent. They sketch the algebra before the page time, a reconstructs from the whole after from E a hand goes up. So where's the firewall? The answer's dry. In bad reconstructions. What nobody knew before the tools matured was how the timing would get set. In friendly models, you can watch the entanglement wedge of E swallow more of the interior as you collect radiation, until a sharp change. The quantum extremal surface jump. Hands you the page time isn't a vibe. It's where the minimal surface changes branch. The bridge you drew on the board is an arc. It's a boundary calculation telling you which operators live where. Impact lands clean. equals EPR offers a picture that keeps no drama for the infaller and unitarity for the accountant, while making the handoff a structural inevitability, not a miracle. The bridges are non-traversable. Nobody's calling the press with faster-than-light tricks, but the wires are real enough to root bookkeeping. And once you grant that, you're ready for the lab where the dictionary stops being metaphor entirely, and every bridge and wire gets an entry. That lab is a bowl-shaped universe with a theory on its edge that never forgets. Add SCFT isn't a slogan. It's the codebase that turns equals EPR into math. Add SCFT when 3D is exactly 2D. Here's the dictionary that stopped being rumor and started being law. Take anti, de Sitter space, add S, a universe with constant negative curvature, like living inside a bowl whose rim reflects light. Now put a conformal field theory, a quantum theory without gravity, on the boundary of that bowl. On November 27, 1997, Juan Maldacena wrote down the claim that turned whispers into a map. The bulk gravity theory in ADS is exactly equivalent to the boundary CFT. Not approximately, exactly. Every bulk field a boundary operator, every bulk event a boundary signature. A higher dimensional world with gravity becomes a lower dimensional world without it. Stakes crystal clear. If the boundary theory is unitary, and it is, then black hole evaporation in the bulk must be unitary. You don't appeal to hope, you appeal to equivalence. The paradox stops being a fight about horizons and becomes a statement about correlation functions in a theory that never forgets. If you can compute it on the edge, it exists in the bowl. If it contradicts unitarity on the edge, it can't exist in the bowl. The ledger's location is no longer a guess. It's the boundary Hamiltonian. Action step by step. Disturb the boundary with an operator O at some time. In the bulk, a wave ripples from the boundary inward along geodesics, reflects and returns, all encoded in a precise kernel, the bulk-to-boundary propagator. 2-point functions on the edge read off how bulk fields traverse geometry. Change temperature on the boundary, heat the CFT, and a black hole forms in the bulk. Hawking radiation in the bowl is just thermalization and late-time correlations on the edge. You send in a pulse on the boundary, a quasi-normal ringed on answers in the bulk. The dictionary translates scenery into spectra. Human moment. A skeptic prints Maldace's paper, skims, scoffs, and sets it aside. A week later, they're computing glue-ball masses by looking at poles of boundary correlators. The speed of conversion wasn't fashion. It was gravity discovering a translator that finally spoke quantum. Meanwhile, another rule clicked into place like a key. Ryu and Takanagi wrote down a simple, surgical prescription. The entanglement entropy of a boundary region equals the area of a minimal surface in the bulk anchored on that region, divided by 4 in Planck units, with quantum corrections when needed. Change the boundary state and the minimal surface deforms, its area tracking entanglement like a ruler made of geometry. It's Bekenstein, Hawking repurposed as a measuring device for quantum information. Surfaces in the bowl are reading off which boundary regions are entangled with which, and by how much. Stakes sharpen when you couple your ADS black hole to a bath so it can evaporate. On the boundary, that's just a hot CFT exchanging energy and information with another system. Global evolution stays unitary. Now compute the entropy of the radiation as time passes. Early on, it climbs, Hawking's answer. After a calculable delay, something new enters the gravity path integral, replica wormholes. The quantum extremal surface jumps and the Ryu-Takanagi prescription with quantum corrections, really, the island rule in disguise, forces the entropy to turn over. You get the page curve from a semi-classical calculation that includes the right saddles. No slogans, a plot. Microstory. A grad student codes a simple holographic quench, tracks the extremal surface for a boundary interval that includes the bath. The curve rises, stalls, then drops. They email the plot at 3 a.m. Their advisor replies 2 words, page time. It's not a prophecy anymore. It's a number extracted from geometry. What nobody expected was how naturally quantum error correction would surface as the architecture beneath holography. Bulk operators inside a region can be reconstructed from multiple, sufficiently large boundary regions. Redundantly, the way a good code stores a logical bit across many physical bits. Lose a piece of the boundary, introduce errors, and you can still recover the interior if your region is big enough. That redundancy explains why the interior partner can be reconstructed from early radiation after the page time without cloning. It's one logical operator with multiple valid reconstructions, depending on which boundary algebra you control. The entanglement wedge of the radiation grows until it swallows the island. The reconstruction rights migrate legally. Human angle, a seminar where someone draws a boundary circle, shades a subregion, and sketches a minimal surface dipping behind a bulk horizon. They point, this wedge is what this boundary piece can reconstruct. Then they extend the boundary region, and the surface snaps to a new branch that threads a wormhole saddle. Now it can reconstruct more, including what we used to call interior. The room doesn't clap. They nod. The snap is the story. Skeptics kept one honest objection. We don't live in ADS fair. ADS CFT is a laboratory, not our sky. But it's a lab where gravity is tractable, where the boundary never forgets, and where the paradox is computable end to end. Every time a calculation needed the fall of the page curve, the extremal surface jumped. Every time geometry needed a reason to bend, boundary entanglement provided it. The lab result doesn't prove our universe runs the same code. It shows a complete, exact example where the ledger lives on the edge and black holes evaporate unitarily with smooth horizons and scheduled payouts. Microstory, a colloquium wrap-up slide reads, who manages memory, the boundary Hamiltonian? A student asks, so the delete button is fake? The speaker smiles. It's a recycle bin with encryption. The room laughs, but the phrasing sticks. Deletion was a misunderstanding. Compression plus scheduled release is the rule. Here's the payoff you've been waiting for. ADS CFT doesn't handwave past the paradox. It demotes it to bookkeeping in a code that's manifestly unitary. Entanglement surfaces act like auditors. Replica wormholes and islands act like clauses in the accountant's manual. The The bridges of equals EPR are the wiring diagram inside the code. And once you've seen it work in a world that's solvable, you stop pretending mystery is the honest headline. The honest headline is management. The page curve, when information fights back. Don Page did something impolite to despair. He graphed it. If evaporation is unitary, he asked, how should the entropy of the radiation change with time? Not hand-waving, numbers. Treat the black hole plus its radiation as one big pure state. Then look only at the radiation and ask how entangled it is with what's left. Draw that as a function of time, and you get a curve with a message. Stakes first. If the radiation's entropy just climbs until the hole is gone, Hawking's shredder wins and information disappears. If it rises, peaks, and then falls back to zero by the end, unitarity survives. That turnover is the tell. It's the smoking gun you can ask any proposal to produce. No turnover, no unitarity. Action step by step. Page's 1993 argument uses typicality in big Hilbert spaces. Model evaporation as a unitary process that gradually moves degrees of freedom from the black hole to the radiation. Early on, the radiation subsystem is small, so it's nearly maximally entangled with the much larger hole. Its entropy rises roughly with the number of emitted quanta. Keep going. Eventually, the radiation becomes the larger subsystem. Typical pure states have the smaller piece nearly maximally entangled with the larger, not the other way around. Past that critical moment, now called the Page time, adding more quanta can't increase the radiation's entropy. It must start to decline to reach zero when the black hole is gone. Up, peak, down. That's the Page curve. Human moment. Page sends Preskill a preprint with the plot sketched in pencil. No fancy numerics, just statistical gravity. Preskill smiles because it gives the intuition teeth. You can debate mechanisms forever. A curve ends debates. Meanwhile, translate the story back into quanta. Early Hawking emissions look thermal locally because each is entangled with an interior partner. That entanglement inflates the radiation's entropy. After the Page time, unitarity demands a switch. New radiation must be more entangled with the early radiation than with any interior mode. That's the monogamy pressure you felt at the Firewall. The curve isn't just a plot, it's a constraint on how entanglement gets rerouted. Microstory, a summer school chalkboard. A student draws a straight line up to the end and says, so it just keeps rising. The room shakes its head. Another draws a sawtooth, cute but wrong. A senior physicist steps up, draws a smooth rise, a peak near half the evaporation time, and a fall. This is the signature, they say. If your fix can't produce this, it's not a fix. Impact was immediate. The Page curve became the test every idea had to pass. Remnants that hoard everything and never pay out, fail. Baby universes that export data to elsewhere, leaving us with ignorance, fail for our branch. No drama stories that never deliver correlations to the radiation, fail. Even Firewall acceptors had to explain how and when correlations appear without breaking causality. The curve turned philosophy into diagnostics. What nobody had for years was a gravity-side derivation. Holography kept insisting the boundary is unitary, so the curve must fall. But Hawking's semi-classical calculation, done the old way, kept spitting, rise forever. The missing piece lived in the path integral's blind spots, saddles the naive calculation ignored. When replica wormholes and islands entered, the extremal surface jumped at a calculable time. The region whose entropy you count grew to include an island just inside the horizon, and the radiation's entropy turned over exactly when Page predicted. Human angle. A grad student runs the island prescription in a simple ADS plus Bath model. Blue curve, Hawking's answer climbs without mercy. Red curve include islands after the extremal surface switch, rises, peaks, falls. They send the plot at 3 a.m. The reply lands in 5 words. Welcome to the Page era. Stakes escalate when you add scrambling. Black holes look like the fastest scramblers allowed. Local disturbances spread in a time scaling like beta log S, with beta the inverse temperature. That sets not just if the curve turns, but how soon meaningful correlations can appear in the output. Early radiation looks like noise. Late radiation carries structure. The delay isn't a bug, it's the price of secure compression. Microstory. A researcher stares at two datasets, one from a toy many-body system coupled to a bath, one from an island calculation. Both curves show the same peak and descent. They scribble decoding window above the fall. It's not that the information was never there. It's that before the peak, you were listening at the wrong frequency. Meanwhile, the curve reframes the firewall. After the page time, the entanglement A, B across the horizon must give way to E, B correlations with the early radiation. That looks like a violation until you realize A is a logical operator whose reconstruction migrates. Before the peak, A reconstructs from the remaining whole. After, it reconstructs from E. Monogamy is safe. You just stop double counting. Skeptics press scope. At S baths aren't our sky, fair. But variations that mimic flat space, boxes, or flux still give the same structure. A no-island saddle first, an island-dominated saddle after. The turnover persists wherever the math is sharp enough. Human moment, a colloquium ends. A student asks, so information comes out late, but can we get it? The speaker shrugs gently. Unitary doesn't mean easy. The curve says it's there. Complexity asks what it costs. The room nods. That's the next frontier, how hard decoding really is. Here's the payoff. The page curve doesn't solve the paradox alone. It tells you what any solution must look like. Rise, peak, fall, because the ledger is unitary and finite. Islands give you the rule that makes the fall a calculation. Equals EPR gives you the wiring that makes it legal. Holography gives you the dictionary that never forgets. The curve is the heartbeat of a managed payout. Islands, the trick they didn't want to explain. Here's the move that sounded like a prank and turned into policy. Islands. The question on the table was simple and merciless. How do you compute the entropy of Hawking radiation without lying to yourself? Hawking's semi-classical method says the entropy rises forever. Page says it must rise, peak, and fall if evolution is unitary. The fix wasn't rhetoric. It was a new way to count what the radiation actually includes once gravity is allowed to do all the work it's supposed to do. Action step by step. In ordinary quantum field theory, to find the entanglement entropy of a region R, you replicate the system n times, glue the sheets along R, compute a partition function, and analytically continue n to 1. It's the replica trick. Gravity adds a twist you can't sidestep. You must sum over all spacetime geometries that fit those glued boundary conditions. Do that carefully for an evaporating black hole coupled to a bath, and new saddles show up, geometries where the N replicas connect through wormholes. Those replica wormholes change which configuration dominates the path integral at late times. What falls out is an extremization rule with teeth. The fine-grained entropy of the radiation isn't always the entropy of fields on R alone. Sometimes you must include an extra region I inside the black hole, a literal island. So the answer is the generalized entropy, area of the island's boundary divided by 4 plus the von Neumann entropy of quantum fields on R union. Then, you extremize with respect to the island's location and pick the minimal value. Early on, the no-island saddle wins, Hawking's result. After a calculable delay, a new extremal surface appears and the island saddle takes over. The curve turns when the surface jumps. Human moment. A postdoc tries to explain this to a journalist and hears themselves say, "The radiation includes a piece of the inside." The journalist blinks. "How?" The postdoc says, "Replica wormholes," then winces. It sounds like a meme. In papers, the phrasing became surgical. Quantum extremal surfaces, dominant saddles, generalized entropy. The core is blunt. To keep unitarity honest, the entropy counting region must sometimes reach behind the horizon. Microstory, group meeting at MIT. A plot appears blue for Hawking's never-ending rise, red for the island prescription that rises, peaks, and falls. Someone asks, "Where is the island?" The The presenter highlights a shaded sliver just inside the horizon, bounded by a surface where the generalized entropy is stationary. Right here, they say. A senior physicist nods once. Then the ledger moved. Meanwhile, the dictionary we trust lined up behind the rule. In holography, the island prescription is just the Ryu Takayanagi formula with quantum corrections extended to spacetimes that include baths and dynamical horizons. The extremal surface that jumps is the same minimal area story upgraded with bulk entanglement. Replica wormholes aren't decoration. They're how the gravitational path integral knows about the code-like redundancy. Once you hold more than half the ledger, the radiation's entanglement wedge swallows an island, and interior operators become reconstructible from the outside algebra. The firewall monogamy trap evaporates because you stop double-counting independent systems. Stakes sharpen with scope. Are islands a trick of Ades with a bath toys? People pushed into Jakku, Tadelboim gravity in 1+1 dimensions, higher dimensional setups with end-of-the-world brains, and constructions that mimic asymptotically flat space by clever couplings. Wherever the math was sharp enough, the same structure appeared. Early times, no island. After the page time, an island dominates. The timing depends on temperature, coupling, and geometry, but the turnover persisted. The rule looked less like a hack, and more like a clause the old calculation forgot to enforce. Human angle again. A colloquium ends and someone careful asks, so the black hole interior is in the radiation. The speaker takes a breath and answers precisely. After the page time, the algebra generated by operators acting on the radiation contains the logical operators that describe excitations in what you'd call the interior. That's what the island tells you. The careful person smiles despite themselves. You rehearsed that. The room laughs because the words matter. The claim is strong and has to land without hype. Here's the part press releases tiptoe around. Islands don't add drama for the infaller. Locally, the horizon stays vacuum-like, no wall of fire. What changes is the accountant's ledger, which degrees of freedom the exterior algebra has the right to reconstruct, and when. Early on, the exterior can't reach behind the curtain. Late, the curtain moves. The page curve falls because the definition of radiation subsystem grows a hidden wing exactly when the extremal surface says it should. Microstory. A late-stage black hole, tiny and hot. Another quantum leaves. If you've been collecting radiation since the beginning and performing impossible, godlike joint measurements, the new quantum clicks into a pattern like a checksum, tightening global consistency. You don't learn meaning from one photon. You enforce integrity across many. It feels less like a leak and more like a scheduled audit passing another line item. Skeptics still press. Do replica wormholes overcount? Are we smuggling in non-locality by hand? The careful answer is that the saddles come from the same gravitational path integral the field has trusted for decades, now evaluated in a regime where multiple topologies compete. Non-locality isn't added. It's the old lesson that gravity reorganizes degrees of freedom under constraints. The rule respects causality, preserves no drama, and produces the page curve. Impact lands clean. Islands make the payout a calculation instead of a hope. They encode the schedule the page curve demanded and the wiring equals suggested. Accept them, and the paradox stops being a riddle. It becomes bookkeeping. Who can reconstruct what when the extremal surface jumps, and how the ledger pays out correlations under a finite budget. Garbage collection, the function nobody will name. If the ledger sits on the boundary and islands mark when the book expands, then a black hole stops looking like a maw and starts looking like a routine. Not a person, not a plan. A routine that nature runs whenever storage pressure spikes. The stakes are blunt. Finite budgets need policy. Without policy, promises like unitarity crack the first time you overfill a region. Start with the pieces we've earned. The area law S equals A4 is a capacity limit, how many independent bits fit on the horizon. Temperature sets a pace. Hotter holes radiate faster. Fast scrambling says the interior mixes inputs in a time scaling like beta log S, with beta the inverse temperature. The page curve adds a schedule. Early radiation is structure poor. After the turnover, structure must appear in the output. Islands give the legal language. Past the extremal switch, the radiation's algebra includes an island region just inside the horizon. That's allocation, compression, and reclamation under constraint. Call the phases what they act like. Phase 1, allocation. Collapse feeds mass energy to the whole. Area grows, capacity increases, and the ledger reserves space the only way gravity allows, by expanding the surface. Phase 2, compression. The whole scrambles inputs almost as fast as physics permits, spreading their imprint across horizon microstates so no small subset reveals anything. Lossless in principle, opaque for any local probe. Phase 3, reclamation. After the page time, the extremal surface jumps and the radiation subsystem gains the right to reconstruct interior operators. Locally, the quanta look thermal. Globally, they enforce consistency across everything you've already collected. The stream carries checksums, not headlines. The process terminates when the area and the budget goes to zero. Human moment. A grad student who also writes software sits through a seminar and whispers to a friend, "That's Marquand sweep." The room chuckles when they say it out loud. The analogy sticks because it fits. Mark, which degrees remain reachable by exterior observables. Sweep. Transfer the rest into the radiation's algebra as the island prescription authorizes, freeing capacity by paying out correlations. A referee once told a team never to write garbage collection in a paper. Fine. The metaphor makes people twitch. The behavior doesn't ask permission. What this isn't, a tinkerer behind the curtain. The manager is the Hamiltonian of the full system, the boundary dynamics in a holographic lab that conserves information, scrambles rapidly, and enforces the page schedule through extremal surfaces in the bulk. Emergent algorithms are everywhere in physics. You don't program hydrodynamics, it emerges from molecules. You don't code elasticity, it emerges from lattices. Here, you don't write garbage collector. You get allocation compression reclamation as a consequence of unitarity plus gravity's storage caps. Microstory, late-stage evaporation. The whole is tiny, boiling hot, and the island covers almost everything you'd call inside. Another quantum leaves. If you've been hoarding the radiation from the start, the new piece clicks into a global pattern like a checksum in a RAID array. One photon tells you nothing. Together, they validate a message you didn't know you were holding. That's not drama at the horizon. That's disciplined release at the edge. Stakes sharpen once you bring in other bounds. Balso's covariant bound limits entropy on any light sheet by 1/4 of its area. Budget enforcement at every surface. Margolis. Levitin ties operation speed to energy. No free clock cycles beyond Eloyd's count tallies total ops since the Big Bang. Finite. Try to store too much in one region and gravity forms a horizon, handing control to a routine that respects all three. The cosmos doesn't just forbid overflows, it roots them into a process that preserves the ledger's integrity. Skeptics push back. You're anthropomorphizing. The better reading is mechanical. Shredder was the anthropomorphism, giving black holes an appetite for deletion they never had. Remnant Vault and Baby Universes were narrative band-aids that bled elsewhere. Garbage collection sounds like IT talk, but it's a clean description of allocation under constraints, aggressive scrambling for security, and scheduled reclamation via islands. If you want a cleaner label, try resource management. The output bandwidth temperature limited, the buffer size area limited, the release policy page timed, the redundancy provided by holographic error correction. Human angle. A physicist sketches an entanglement graph, nodes for subsystems, edges for correlations. Black holes appear as bursty hubs. Input edges surge during collapse, local connectivity thickens during scrambling, and outbound edges proliferate after the page time as correlations get re-exported. They write reallocation under load in the margin, then cross it out. They know the word load will make someone roll their eyes. The sketch stays because it matches the math. Meanwhile, the routine protects more than slogans. It preserves equivalence for infallers by keeping the local horizon state vacuum-like. It preserves causality because the bridges that route bookkeeping are non-traversable until you add controlled couplings. It preserves unitarity because the boundary Hamiltonian never forgets. It even protects you from scams. Any attempt to beat the bounds triggers geometry to redraw the ledger. New area, new clause, same discipline. Here's the payoff that people avoid naming because it sounds like heresy. Black holes aren't cosmic delete buttons. They're compression engines with delayed, authenticated output under a hard budget. The paradox wasn't a mystery, it was a missing ops manual. Islands filled the clause. equals Epper drew the wiring. The page curve set the schedule. The boundary runs the code. And once you admit the routine is real, a bigger question sneaks in from the hallway. If a black hole is the OS under pressure, what's the universe running at scale, where the budgets, clocks, and policies don't whisper, they rule? The limits when reality hits storage caps. Zoom out from a single horizon to the whole ledger. If black holes run reallocation under pressure, what caps does the wider universe enforce? The stakes aren't poetic. If reality has hard limits on storage and speed, then every galaxy, every brain, every experiment runs inside ceilings that won't budge for cleverness. When systems hit ceilings, policy shows up as law. Start with storage. Raphael Balso framed a rule that refuses to soften, the covariant entropy bound. Take any light sheet, a bundle of light rays fired orthogonally from a surface and converging, and the entropy that can pass through it is at most a quarter of that surface's area in Planck units. Read that twice. Not volume, area. Try to push more entropy through, and gravity focuses the rays until they form a trapped surface. The bound protects itself by birthing a horizon that raises the area and reasserts the limit. Gravity isn't a bystander here. It's the auditor that expands the ledger when you try to cheat. Now add speed. Quantum evolution isn't free to sprint. The Margulis, Levitin bound says a system with average energy E needs at least pi/2e time to evolve to an orthogonal state, a fully distinguishable change. Energy acts like a processor clock. No matter how you wire the machine, you can't execute distinct operations faster than your energy budget allows. Seth Lloyd ran the cosmic arithmetic. Multiply the universe's energy by the age of the cosmos, and you get a finite count of elementary operations, roughly 10^120 so far. That's not mysticism, it's a ceiling. Every correlation, every structure, every memory in the observable patch lives inside that budget. Human moment to make the ceilings tactile. The cosmic microwave background is a fossil log. We call it a picture of the early universe, but it's really a saved file written at a finite resolution, the best the cosmos could store as photons decoupled. Those acoustic peaks we measure aren't infinite precision whispers, they're what fit on the drive. Decades later, better telescopes don't reveal new bits at the same scales because the file never had them. Cosmic variance rubs that in. With one sky, the statistical noise from finite samples doesn't go away. No instrument can summon more modes than exist. Meanwhile, gravity enforces budget discipline in smaller theaters. Try to cram too many excitations into a region, and you don't get a denser library, you get a horizon. The system hands control to a routine you already met. Allocation by area, scrambling, delayed payout by islands. The same caps that shape the cosmos force local systems into managed behavior when pushed. The delete fantasy evaporates. Resource management takes the wheel. Stakes escalate when you mix storage and speed with decoding. Unitarity says information isn't lost. The bounds say storing and processing it takes space and time. Complexity adds a cost column. Even if the information about a collapsing star sits in Hawking radiation after the page time, extracting it might require circuits whose size or runtime scales beyond any feasible resource. You get a new kind of limitation, practical irretrievability without fundamental loss. The ledger is honest. Your budget isn't big enough to read it. Micro story. A lab hunting primordial gravitational waves upgrades sensitivity year after year. Their models say a faint signal may exist. They slice the sky differently, cross-correlate maps, and ring out foregrounds. Then they hit the floor, sample variance at low multipoles. They're trying to ask the universe a question more detailed than the number of bits available in that patch allows. Their proposal's conclusion reads like a confession. The limit isn't our instrument, it's the sky. Meanwhile, the holographic hint refuses to fade. Bekenstein's area law started local. Bauso's bound made it covariant. Minimal surfaces in holography turned it into a ruler for entanglement. The pattern is boring in the best way. Boundaries hold budgets, geometry enforces them, quantum rules set the clock. Wherever we can compute cleanly, the area wins and timing laws follow. Whenever we pretend volume carries the count, gravity corrects the invoice. Human moment. A theorist doodles a graph of graphs, nodes as regions, weighted edges as mutual information. They watch as adding energy thickens edges only to trigger a horizon that prunes connections and reroutes them through a hub. They write, network saturates, hub allocates, then hesitate. It sounds like systems talk. They leave it. In the morning, it still fits. Here, S where the implications lean in. If storage and speed are finite, then what we mean by precision, permanence, even identity thins into patterns that must be redundantly embedded to persist. A civilization that wants its music to outlast its stars can't just save it. It must spread it across substrates, hedge against erasure by entropy, and pay the decoding costs forward. In a managed world, eternity is an engineering problem with a line item for energy and an invoice from gravity. Skeptics push the same line. This sounds like a simulation. The honest answer is dull. Code-like behavior emerges when laws enforce budgets and redundancy. Holographic error correction doesn't need a programmer. It needs a boundary Hamiltonian. Islands don't need intent. They need a path integral with the right saddles. We built computers that act like physics because we learned from physics, not because the universe borrowed our software metaphors. Final human moment for the ceiling. A student asks in office hours, "So what's the point if the ledger keeps everything and we can't read most of it?" The professor thinks, then says, "Meaning lives in the patterns you can actually access, preserve, and share under these limits." The student nods slowly. Limits aren't insults. They're rules, and rules once known can be played. The punchline is that the universe deletes. It's that the universe budgets. It caps storage by area, clocks operations by energy, audits flows with geometry, and routes overflows into routines that keep promises. Black holes weren't exceptions. They were the loudest enforcers of rules that were always there. The lie exposed why paradox was safer. By now the pattern's hard to miss. Area laws set budgets. Entanglement surfaces act like auditors. equals EPR gives you a wiring diagram. Islands enforce the payout schedule. So why did paradox keep its seat at the table? Because paradox was safer. It told the public, "We don't know," while telling insiders, "Don't say what this implies." It protected reputations, buffered grant narratives, and postponed a culture war about what managed physics sounds like outside the building. Stakes first, and they're human. If you say managed information, people hear designer. Departments don't want headlines that drag them into metaphysics. Funding panels don't want to be accused of underwriting teleology. Textbooks resist tearing down a clean story. Bulk holds stuff, horizons hide it, and replacing it with boundary ledgers, error-correcting codes, and access rights. Paradox, let everyone nod solemnly without confronting a conclusion that feels like engineering. The universe keeps books. Action looked like language discipline. Colloquia ended with the paradox remains open, even when the middle of the talk showed a page curve from islands. Press releases used mystery, while figures displayed extremal surface jumps that made the turnover inevitable. Papers said consistent with unitarity, where unitary in this setup would have been honest. You could hear the subtext: don't poke the bear, don't invite misreadings, don't turn math into a culture fight. Human moment. A junior researcher drafts an abstract. We derive the page curve via replica wormholes. Evaporation is unitary in our model. Their mentor marks it up. Derive right arrow compute. Is unitary right arrow consistent with unitarity? Our model right arrow a simplified setup. None of those edits changes the result. All of them change the temperature. The junior looks at the track changes and sighs. They don't want to be a martyr for a headline. They also don't want to pretend the math didn't speak. Micro story. A department media officer rewrites a summary from radiation includes interior degrees after the page time to new geometries may change how we think about horizons. The physicist lets it pass. The public gets fog. The field avoids a week of takes. The cost is clarity. Meanwhile, the inside conversation moved on. Holography made boundary unitarity non-negotiable. Ryu Takuyanagi made entanglement into area with quantum corrections. Replica wormholes made the page turnover a saddle point switch. Entanglement wedges made reconstruction a right tide to which boundary pieces you hold. The paradox didn't vanish because the question was trivial. It vanished because the machinery made the outcome routine. No loss, no drama, scheduled payout. Paradox kept getting said out loud while policy got written on the board. What nobody liked to admit is that paradox also concealed fear of the next steps. If you call black holes resource managers, you invite questions about the rest of physics. If storage and speed are capped, someone will bring up complexity costs, meaning identity. If error correction is native, someone will say simulation. Even if you don't need a programmer, the metaphors smell like code. Paradox. Let scientists stay in the business of equations and avoid becoming unwilling philosophers on camera. Human angle, a hallway chat after a talk. A student asks, "So, is the paradox solved?" The speaker glances at the door, then answers, "In the setups we understand, yes, up to decoding cost." The student smiles. "Why didn't you say that on stage?" The speaker shrugs. "It's easier not to fight the word." The conversation feels both honest and compromised. Impact of keeping the brand was predictable. The public learned to love a question mark where the literature had drawn a curve. Students met mystery in lecture slides and island prescription in the reading. Popular books sold the shredder. Meanwhile, researchers built decoding protocols, toy traversable wormholes, and flat space extensions. The shop floor built while the storefront sold wonder. It kept everyone comfortable and left the core truth underlit. Black holes don't delete, they schedule. Micro story, a grant review. One panelist circles a line, "Our work resolves the paradox in JT gravity," and writes, "Overclaim soften." Another circles, "We compute the page curve," and writes, "Good." The pi removes resolves and keeps compute. They get funded. The science didn't change, the risk profile did. Here's the part that matters more than optics. Naming the fix changes the questions. If you accept that boundaries carry budgets and reconstruction rights shift by rule, you stop asking, "Does information survive?" and start asking, "What does it cost to decode?" If you accept islands, you stop fearing horizons and start timing surface jumps. If you accept equals epper, you stop arguing metaphors and start designing couplings that make bridges effectively traversable in labs without breaking causality. Paradox was a holding pattern. The work now is logistics. Skeptics have a fair caution. ADS isn't our universe, true, but a single exact lab where everything is calculable and unitary is enough to retire the shredder. You don't need every sky to match to learn the rule. Gravity reorganizes information under constraints. Horizons enforce budgets, not oblivion. Extending to flat space is an active frontier. The core lesson doesn't wobble with the curvature sign. Human moment again. A senior physicist, once a skeptic, stands at a whiteboard after a seminar and draws two curves. Hawking's rise and the page curves rise and fall. They tap the second. "This is what we teach now," they say quietly. "We just don't say it too loudly." Then they erase the board and head to lunch. The lie wasn't that there was a problem. The lie was that the solution was a rumor. It's policy now. Boundaries budget, wormholes wire, islands schedule the payout. Call it managed if you must. Call it emergent law if you prefer. The labels don't change the ledger. The only honest headline left is the one that risks less poetry and more responsibility. The universe keeps its receipts, and black holes file on time. And if that's true, you can't leave the implications at the door. Once you accept budgeting over deletion, the next questions aren't about mystery, they're about costs and choices. Which brings the conversation out of seminars and into your hands. Lived inside a ledger, implications you can't ignore. Identity is pattern. Survival is preserved correlations. Death reallocates processes. Meaning becomes stewardship. Redundantly encode budget energy, design recoverable futures. If the universe keeps accounts instead of erasing, then permanence is a design problem, not a prayer. What you keep depends on where you write it and how often you mirror it. This is why decoding cost matters. What survives in principle may be unreachable in practice without redundancy and power. And that's the setup for the reckoning you can't outsource, choosing what to preserve and paying the bill. The reckoning, choosing what to believe. This is where the math stops being a spectator sport and starts asking something from you. You've walked the budget, the area law. You've watched the auditors, entanglement surfaces, snap from one branch to another. You've seen the wiring, equals EPR, drawn as bridges you can't fly through but can still use for bookkeeping. You've watched islands shift who gets to reconstruct what and when. Now the choice isn't philosophical flair. It's a fork between two ways of living with what we know. On one side sits the comfort of mystery. Keep the word paradox, float in open questions. Say black holes might delete, horizons might hide forever, and maybe the ledger blinks. It's an easy story to sell. It keeps awe without obligation. It lets you look at the night sky and call ignorance a virtue. The other side is less warm and more precise. The universe is finite and unitary. It budgets storage by area. It clocks updates by energy. It routes overflows through routines that scramble, then release on a schedule. There's no clerk and no kindness, just discipline. That discipline binds you too. Here's the reckoning in plain language. If you accept the managed view, then every pattern you build has a bill. Storing it takes area somewhere. Maintaining it takes energy. Making it recoverable takes redundancy. There is no deletion, only diffusion into correlations you may never have the resources to decode. That doesn't strip meaning, it prices it. It pushes what you care about into what will you pay to preserve in time, power, and attention. Human moment. A researcher who spent a decade on the paradox catches themselves gripping the back of a chair. They realize they're less afraid of a firewall than of a ledger that remembers more than they can bear to leave behind as noise. They think of their kids' drawings on a fridge and the backups they never made. The problem stops being cosmic for a second. It becomes a tiny, domestic choice. What to copy, where to store it, who will be able to read it when they're gone. Meanwhile, the managed view doesn't smuggle in a designer. Keep your naturalism. The manager is the Hamiltonian. The policy is constraint. Emergence is the whole trick. Codes out of many-body physics, bridges out of entanglement, islands out of saddles. The universe looks like software at scale because we built our software to borrow physics' best habits. Redundancy under error, locality until you can't afford it, global integrity enforced by simple, ruthless rules. It's not someone's computer. It's what finite, unitary law does when pushed. So what do you do with this? First, you retire the shredder story. Information isn't erased in black holes. It's compressed, delayed, and released in patterns you can, in principle, decode with unreasonably large patience. Second, you pivot your curiosity. Stop asking whether reality loses memory and start asking what memory costs to access. That's complexity, not mysticism. How hard is it to reconstruct a diary thrown into a hole from the radiation years later? Hard enough that no civilization we can picture can do it, but not forbidden. And that gap between possible and practical is where agency lives. Microstory. A small team sits in a windowless room testing a tabletop wormhole protocol, a pair of entangled cold atom systems with a controlled coupling that makes a tiny signal pop out on the other side. Nobody's teleporting matter. Nobody's bending spacetime. They're routing correlations through entanglement they prepared. It's fussy, it's finicky, and it's a sliver of a future where we stop arguing metaphors and start engineering access to patterns under the rules we've learned. Third, you treat meaning as stewardship. In a finite, unitary world, your choices write to a ledger that never forgets, but recovery isn't free. So you choose which signals to amplify, which redundancies to build, which formats won't rot. You design for beings like you with budgets like yours. You make it easier for the next person in your chain to read what you meant. That's ethics minus incense. It's also strategy. Skeptics will push one more time. You've built a castle in Hades Fair. Our sky curves differently, but one exact laboratory is enough to retire the myth that physics enjoys deleting. One lab showing unitary evaporation with smooth horizons and scheduled payouts is enough to force a bias. If your story depends on loss, you carry the burden. Extensions to flat space are live. The discipline hasn't blinked in any setting where we can compute. Human moment. A student corners a speaker after a talk and blurts, "So what am I supposed to believe?" The speaker doesn't hand out a creed. "Believe what you can calculate," they say. And when your words outrun your math, slow down. The student looks down at their phone, the device that turned physics into culture, and nods. They're carrying a pocket ledger bound by the same rules. Storage is finite, power is finite, recoverability is a choice. Now one last friction. If you accept managed reality, awe doesn't shrink, it sharpens. The night sky stops being a canvas for infinite possibility and becomes a sculpture chipped out of constraints, area caps, speed limits, and codes that won't budge. Galaxies collide inside budgets. Life emerges inside budgets. Love writes itself into noisy substrates and survives by redundancy. Black holes, once the villains, turn out to be the universe's stern librarians. They accept overdue returns, compress them ruthlessly, and eventually mail you back the catalog in tiny, encrypted postcards. So pick your story. Keep paradox if the word buys you peace, or take the ledger if you want the responsibility that comes with a world that never forgets and rarely forgives sloppiness. The first makes a good poster. The second tells you how to live. Build patterns worth their cost. Replicate what matters. Align your intent with what the rules will let you keep. The math doesn't demand reverence. It asks for craft. And once you choose the ledger, one more uncomfortable thought lands softly. If black holes aren't delete buttons, they're proof by example that the universe refuses to throw anything away. That refusal might be the closest thing to mercy physics ever offers. It doesn't save you from entropy. It hands you a budget and dares you to do something permanent with it. That's the quiet punchline. Black holes weren't shredders. They're disciplined compressors running on a finite ledger that never forgets. The blinking light on Hawking's desk wasn't a warning of deletion. It was a signal that the audit had begun. From March 1, 1974 to islands and page curves, the math kept saying the same thing. No loss, just budgeting and delayed release. The question left for us is simple and heavy. What do you build that's worth the cost to keep? Subscribe to Cosmic Ventures for more true stories behind polite headlines. And watch the follow-up on the universe's memory limit and where decoding breaks first. If you think we overreached, point to the equation.